plus OBA plus OAB, because the minus and the minus becomes plus. And what do we do now? Anyone? Anyone? I might have to start picking on people. You there?
So, as you've got it as it is, it looks as though it's all 4 different angles. But you can figure out which angles are actually equal to each other and figure out where they are.
So this is where we use this. Okay, so here I have ODA and OAD, and I have that they're equal. So like I could replace ODA with OAD, or I could replace OAD with ODA. Which one should I do? The first one. Why? Yeah, because we're trying to move. Right now we've got that angle, that one, and that one. We're trying to move all our angles to there, and hopefully everything will work out, and we'll get just twice that. Okay, so we're to replace ODA with, so ODA plus OAD becomes twice OAD. And similarly for there, we have twice OAB. Cool, now it's kind of easy. We take out the factor of 2, OAD plus OAB. If you look here, OAD, OAB combines to give you DAB. Cool. And there you're done. Cool. Now, what's the problem with this proof? There is a problem. Anyone, teachers, welcome. Yeah.
Could you say it's because you haven't given reasons?
In this case, no, because, okay, so usually, so the stuff we've used are that, so we've used that isosceles triangles have the same angles, or, yeah, we used that, and we used the fact that angles around a point add up to 360, and angles in a triangle add up to 180. So for that stuff, you wouldn't need to give a reason. But like if you're using something which is more advanced, you would need to give a reason.
You haven't looked at all the cases.
Yeah, exactly. So usually in a paper they would tell you there's a circle, center O, points A, B, and D on the circle, prove that that angle is twice that angle. And you go and you draw your sketch and you get it and you prove it, but you haven't considered all the possibilities. There's also a possibility that it looks like this. There's O, A, D, B. And this doesn't work as well as, well, I mean, you basically have to do a separate proof for this case. Unless you use directed angles, which is a slightly more advanced topic. Basically, you can have positive and negative angles. And then that would take care of both cases, but that's not what we're going to do now. Cool. How much time do I have? What time is it? 1:45. Okay. Shall we prove another simple thing or a slightly less simple thing? Less simple, okay. Do we have any suggestions, votes, stuff you want to see proved? You want, okay, you want to, okay, who wants to see the proof that the Simpson line is a line? Exactly. Okay, so we can do that, and we will do that unless someone else comes up with a good idea. Anyone, please. Please. Something to do with circles and points. Oh, point it is. Okay. So, this power point is actually useful. I've never seen Simpson line actually being used in reality. Okay.
Yeah, please use it differently.
This one. Okay. Okay, so you've got a circle, gamma, and you got a point P. Let's say you've got two lines through the circle, intersect at A and B, and C and D. Okay, prove that PA times PB is equal to PC times PD. Okay. How much stuff do you guys know about circle geometry? Basics, have you done cyclic chords?
Yeah.
Yes, okay, good. Cyclic chords are good. So that's, cyclic chords is basically more or less all you need here. Kind of, not really. Okay, so this is how you prove it. You connect these points B and D, that is a line, and A and C, and you've got a cyclic chord. Okay, so the proof would be something like this. ABCD is a cyclic quadrilateral. Okay, so you know some stuff about angles and cyclic quadrilaterals. Okay, so you would know that angle PAC is equal to angle CDB. Okay, so would you know that? I've got one yes. Two yeses? Three? I think that was three. Yeah, I've got a nod. I've got a vigorous nod. Okay. Do I have any no's? No. Okay. Okay, so you guys see why that's true? I mean, one way to do it is, okay, so you can either just remember that internal angle of a cyclic quad is equal to the external angle on the opposite side, or you could remember that these two add up to 180 and that adds up to 180, so that equal to that. Okay. And PCA is equal to, okay, so it's actually, let's make this alpha make that, that should be alpha as well. Make that beta, D, E, A. Yes, that's beta. Okay, so now there are two triangles there which are similar. Which two triangles are similar? That's all I heard. Can I have someone a little bit louder? A little bit louder? Therefore, what is it? PAC, the triangle PAC is what's the symbol for similar? That one. Triangle P. What's the other one? GB. Okay, so when we said that these triangles are similar, would you say that there's a little bit of a